Hey Predents, so today we're going to be talking about periodic table trends, and we're going to be going over some high yield topics that you'll likely see on your DAT. The first trend I'm going to be going over is atomic radius. So as you move down and to the left, your atomic radius increases in size. First, as you move down the periodic table, you increase the number of electron shells. The second thing affecting the size of the atomic radius is what we like to call the effective nuclear charge. And as you go left to right, you actually increase the effective nuclear charge, which is just the number of protons you have minus your core electrons. So really quickly regarding the size of atoms, we need to hit a topic that goes into detail about atomic radius versus ionic radius. First, we're going to talk about ions with a positive charge called cations. So right here we have lithium ion and we have lithium. So by lithium ion losing a valence electron, all that has left is its core electrons. Therefore, it is going to be smaller than your typical lithium atom. Next, let's talk about anions, which are ions with a negative charge. So chlorine has an additional electron in this chlorine ion right here, which increased the size of its electron cloud. Therefore, its radius is going to be larger than just regular chlorine. So your real takeaway from all this is that cations, positively charged ions, are smaller than a neutral species, and anions are larger than a neutral species. The second trend I want to talk about is ionization, which increases as you move up and to the right of the periodic table. All ionization is the energy it takes to lose electrons, and this process, since it takes energy, is what we call endothermic. That is a very high yielding point right there, so make sure you remember that. So now we need to talk about the difference in the types of electrons you remove from an atom. So if you are removing a valence electron from the atom, it takes a small amount of energy, and as you remove another valence electron, the energy increases by a small amount. However, once you have removed all the valence electrons and are now removing core electrons, you see a very large jump in the amount of energy it takes to remove that electron. So some special cases that you need to know for the DAT. Atoms really like to have filled shells. So in the case of boron, right here, it has an additional electron that is not in a shell that is filled. So it is more likely to go ahead and lose this electron so it can become more stable, and which will change its atomic identity to beryllium. So nitrogen has its p shell half full and is better off than oxygen because it actually wants to lose this electron right here, because electrons repel each other, and since it's paired in the same orbital, it creates tension within that orbital. Next, we're going to go over electron affinity, which is pretty much the opposite of ionization. It is the change in energy when you gain electrons, and it is typically exothermic, meaning it releases heat, and the atom that has the highest electron affinity is actually chlorine, and it increases as you move to the right of the periodic table. So another way to say it is that electron affinity is associated with reduction, and that ionization is associated with oxidation. With sharing electrons, such as in covalent bonds, and the larger the difference in electronegativity between the atoms, the more polar the bond is. An example of this would be having a hydrogen covalently bonded to fluorine. As you can see here, the fluorine is very electronegative and the hydrogen is not. Therefore, we're going to get a dipole moment and a polar bond. So that wraps it up for periodic trends. All this information should be sufficient to get you through the DAT. The DAT doesn't go into too much detail. It's more about just knowing a lot of information and being able to apply it. So I hope these videos help. If you like this video, please like it and subscribe to my channel, and I will continue putting out more chemistry videos. And good luck to you guys.